Let us look at this problem here. So if I have a set A, suppose, which consists of uh, the numbers 1, 2, 3, 4, 5, 6, okay, which is defined on the relation R, um, uh, which is from A cross A, that is A to A, uh, which is uh, which is given as, I can write this as R is equal to uh, x comma y, such that y is equal to x plus 1. Okay. Now, we know this a set which consists of uh, how many elements? Here you have 6 elements. So here R is defined as y is equal to x plus y, right? Let us write down what all the relations we have. So uh, for x is equal to 1, you have y as 2. For x is equal to 2, so we'll take all the elements here, that is 1, 2, 3, 4, 5, and 6, and so on, right? To 6, right? So y will be 3, x is equal to 3, y will be 4, x is equal to 4, y will be 5, and x is equal to 5, y will be 6. Okay. So these are the relations which we get. So those are R as according to this, which is 1 comma 2, 2 comma 3, 3 comma 4, 4 comma 5, and 5 comma 6. So if you look at this in, say, A cross A, so 1, 2, 3, 4, 5, and 6. Again, 1, 2, 3, 4, 5, and 6. So 1, if you look at this, here you have the relation which is 1 comma 2, 2 comma 3. So can you tell me the domain of this? The domain will be 1, 2, 3, 4, and 5, right? That is the first elements, and the range will be 2, 3, 4, 5, and 6. Fine. So which is the second element of which is in this, right? Now let us have a look at how we can relate it to whether it is equivalence or not, right? To prove that it is equivalence or not, we have to prove that it is reflexive, symmetric, and transitive. Let us have a look at that. So as I was looking at this, we have this set A, which consists of 1, 2, 3, 4, 5, and 6, and the relation which is x comma y, such that y is equal to x plus 1. Okay, is it reflexive, symmetric, or transitive? Okay, we got all the relations, which is 1 comma 2, 2 comma 3, 3 comma 4, 4 comma 5, and 5 comma 6. Right? Now, um, to check whether it is reflexive or not, okay. So reflexive is that you have a comma a, right, which should belongs to R, which should belongs to R. Then it is reflexive. So let us see here. Is it possible 1 comma 1 or 2 comma 2? Does it belongs to R? So as you have seen that R consists of 1 comma 2 and 2 comma 3 and 3 comma 4 and 5 comma 4 comma 5 and 5 comma 6. So these 1 comma 2, 1 comma 1 and 2 comma 2 does not belongs to R. So hence it is not reflexive. Okay. Now let us check whether it is symmetric. Okay, for symmetric, uh, what you got to do is, that is, suppose uh, you have a comma b, right? That belongs to R. Then b comma a also belongs to R, right? So is it possible? So let us take one of uh, the things which is 1 comma 2, right? So 1 comma 2, we already seen that if I, this is x and this is y, so 2 is equal to 1 plus 1, that is 2, right? You got 2. But suppose if I put 2 comma 1, okay, which is symmetric, so 1 is equal to 2 plus 1, so which is not satisfying. So you can say 1 comma 2 belongs to R, but 2 comma 1 does not belongs to R, right? If both belongs to R, then we can say it is symmetric. So hence it is not symmetric. Okay. Now let us look at next part of it is transitive. Transitive is the case where A comma B belongs to R and B comma C belongs to R, and then you can write C comma A or A comma C belongs to R. Then it is transitive. Now let us look at 1 comma 2 and 2 comma 3. So as we have seen here in this case, so 2 is equal to, that is y is equal to x plus 1, right? So 2 is equal to 2. This is possible. Now 3 is equal to 2 plus 1. Also 3 is equal to 3. What about uh, the other case, which is 1 comma 3? Okay. Now your y is 3 and x is 1. So 1 plus 1, which is not equal. So 3 doesn't hold good, right? For this, 3 is not equal to 2. So we can say that that is 1 comma 3 does not belongs to R. Okay. So hence we can say that it is not transitive.